The Nanyang Technological Institute provides a practice-oriented engineering education that integrates the academic world with the real world of professional engineering practice. The link between these two worlds is encapsulated in the 10-week in-house practical training course of the School of Civil and Structural Engineering. This course provides a unique and complete instructional package which incorporates an interplay of real engineering practice and pedagogical principles. The in-house practical training program takes place at the end of the second-year course and involves the planning, design, and construction of a full-scale structure. In 1983, the first in-house training project was the construction of 5 reinforced concrete sheds with hyperbolic paraboloid roofs, which housed part of the CSE construction laboratories. In 1984, a 30-meter-long spectators gallery for a sports ground was built. Last year, a multi-purpose games arena was built near the NTI Sports Complex.
Inspired by the success of the last 3 IHPT projects, this year the school embarks on the construction of a double horse saddle roof structure, each measuring 12 meters by 12 meters. This structure, which will form part of the proposed CSE experiment station, is the most ambitious and challenging project. This roof structure has 2 significant features. First, it is multidisciplinary in approach. Hence, the National University of Singapore School of Architecture was invited to participate in the project. The second feature is the innovative and unconventional construction technique. To ensure that students do not have to work at great heights, a task force of academic staff, consulting engineers, and contractors brainstormed various methods and finally decided to build the roof at ground level and then raise it to a height of 3 meters by hydraulic jacks. The design, planning, and implementation are crystallized in these 5 volumes.
The roof structure consists of hyperbolic paraboloid roofs, supporting spine and tie beams, columns, and footings. To design and raise the structure requires accurate analysis. Thus, a prime 750 computer and finite element methods are used. As part of the total instructional package of the IHPT training, the students are also given exposure to and hands-on practice on computer-aided design and drafting applications. Students had to spend 2.5 days in the computer laboratory to study and generate the formwork profiles of the roof structure.
The actual construction of this structure takes 9 weeks and is carried out by all 222nd-year students. These students are divided into 8 construction companies, playing the various roles of management staff, office staff, and site workers. These roles are rotated weekly to ensure that every student has the opportunity of participating in every aspect of the construction project. Every Saturday morning, progress reports are presented by the management group to the rest of the team members. Together, they review difficulties or problems encountered during the week on project monitoring and reporting, quality control, safety enforcement, and disciplinary control. Students are also given some experience in financial management and accounting. They have to be responsible for estimates of quantities of materials required and purchasing of materials and tools from the stores.
Welcome to the IHPT project of 1986. Right now, I'm standing at the site where the CSE experiment station is being erected. This place is also of great historic significance, as this is the very place where the CSE IHPT programs all began in 1983.
The first task to be done is the surveying and setting out of the site. This includes checking the location of the board piles, which, because of our tight schedule, were already installed before the training program began. This is a flashback of how the concrete board piles were installed. There were altogether 8 board piles, one at each corner of the roof. The earth boring was carried out by these machines. After the steel reinforcement cage had been placed inside the hole, fresh concrete was poured down the shaft. The heights of these steel reinforcement bars have to be checked carefully before a steel pile cap is placed over them.
Additional test piles are located at one corner of the site. These are for the geotechnical project incorporated into this IHPT program. The task set for this exercise is to conduct some investigations to check the failure strengths of the piles. Loads are applied and the movements of the piles are then analyzed. The first task of the actual construction consists of setting out and building the temporary footings at the corners of the roof structures. You can see some of our team members fabricating the wooden formwork for the footings, while other students are preparing and checking the level of the reinforcement rods at the top of the piles. Meanwhile, some other students are getting ready the steel reinforcement bars, which have to be cut and bent according to the design drawings.
On top of the footings, we have to position these anchor bolts. One of our important tasks is to ensure that the bolts are correct in level, position, and alignment, as mistakes here can be very difficult to remedy after concreting. This is the steel pile cap inserted on top of the pile reinforcement. It has to be positioned at exactly the right level. For concreting, we use ready-mixed concrete delivered to us by trucks. We have to coordinate the timing well, as we have to make sure that they are delivered to us in time. We compact the fresh concrete by using a poker vibrator. To ensure full compaction, we had to vibrate it for an adequate period of time. Shoddy work or error will have to be rectified before we are allowed to proceed onto the next stage of work. Finally, the top surface of the concrete has to be troweled manually to ensure a smooth surface. Concrete is also filled in the void space of each steel pile cap to set it in place.
The next stage of our operation is the construction of tie beams. These tie beams are built at the base of a shell roof. We first set out the alignment accurately in relation to the steel pile caps, which have just been installed. We then follow this alignment to position a tie beam formwork. The steel reinforcements are then carefully set out inside the formwork, especially at the corners where two tie beams meet, as this is an area of heavy congestion of bars. On top of the temporary footings, we install these steel lifting frames which will be used to lift up the tin shell roofs. The lifting frames are fabricated and positioned carefully on top of the footings. Then they are firmly installed by means of these anchor bolts. On each frame, we have to position 3 high-strength lifting rods. They stretch from the intersection corners of the tie beams to the top of the steel frame, where we have this lifting chair, which is actually the base of the hydraulic jack. At this stage of the construction, the 8 lifting frames for the 2 roof structures are now in place.
Quality control was stringently enforced by a construction engineering committee comprising a few lecturers. Here, you see a staff member checking on the correctness of our steel reinforcement against the design drawings. After the formwork for the tie beams has been checked for size, spacing, and cleanliness, it is now ready for concreting. By now, we have more experience at concreting and are able to keep a consistent level of workmanship. We are more efficient in using the vibrator to compact the concrete.
Here we can see our team members taking samples of the concrete to prepare for slump tests and for concrete cube tests. The tests have to be done for every truckload of ready-mixed concrete to check on its quality and strength. We try to ensure that every member of our team has an opportunity to try his or her hand at every aspect of the construction work. In another corner of the site, the templates for the roof formwork are being fabricated. Because of the enormous size and irregular shape, each template has to be fabricated on the flat ground before it is hauled into place on top of each tie beam.
Hi, I'm Andrew. We are now in the 5th week of the in-house practical training. The construction is progressing very smoothly, thanks to the weather. We have so far completed the tie beams and the temporary footings. The red frames that you see are resting on the temporary footings. These frames will be used later on in the lifting of the main roof structure to its final position. This operation of lifting will be aided by hydraulic jacks, which will be later fitted on the top of the lifting frames. The bars that you see sticking out from the corners of the tie beams are the starter bars for the spine beams. The spine beams are the skeleton for the main roof structure. At present, we are working on the setting up of the spine beam formwork and the site templates.
This is the 6th week of this in-house practical training. We are now doing the formwork for the roof profile. As you can imagine, this double curvature shell roof is quite unconventional. After the completion of the formwork for the spine beams, which we saw last week, we have since then erected the last template for the quarter of this roof shell. For the roof portion, we define various points on the top edge of the template and join them up using straight timber joists. These whole series of parallel straight timber joists will form the profile of the roof. When these timber joists are properly supported and secured, plywood will be placed over them to form a continuous surface. After that, reinforcing bars will be placed over this surface.
You can now see the curvature profile of the roof slowly taking shape as the fabrication of the roof formwork is near completion.
After the roof formwork has been checked for its rigidity, its cleanliness and its correct placement of steel reinforcement, it is now ready for concreting. But this is no easy task because the slope of the corners of the shell roof is 45 degrees, and this is very steep for concreting by any standards. We start concreting from the lower end of the roof corners, and we gradually move upwards towards the center, following the profile of the spine arch. And to achieve the uniformity of the shell roof, of the varying thickness of the shell roof, we have to place the metal thickness markers at 1 meter apart. A 50mm low slump concrete is used so that the concrete will not flow down during concreting. High strength concrete is selected because we want to achieve early strength so that the formwork can be removed as early as possible.
To prevent shrinkage cracks from forming along the surface of the roofs, we use water spray at half-hour intervals to keep the surface moist. Wet gunny sacks are placed over the concrete and kept wet for 3 days. While waiting for the concrete to cure, members of our team are busy constructing the drainage works. The precast channels are carefully laid and aligned. An inspection chamber for a drainage line is constructed. Before we remove the props and strike the formwork, we are briefed on the dismantling procedures. This part of the work has to be meticulously carried out to avoid damage to the hardened concrete. The construction work reaches a climax after the dismantling of the formwork and false work.
This is the moment we've all been waiting for, the jacking up of the two roofs by synchronized hydraulic jacks.
The lifting of the roof is being carried out by 4 100-ton hydraulic jacks, which are mounted on top of the lifting towers. Now these jacks are fully synchronized with sophisticated control, which will ensure that the 4 corners of the roof will go in equal amounts. When we have made the roof ascend 2.5 meters, we will insert the columns, and these will be secured with bolts and nuts. And the lifting jacks and the lifting towers will be dismantled.
The in-house training reaches its climax when the students make their boardroom presentations before a panel of academics and eminent industrialists. Each of the 4 companies will vie with one another to secure the contract to design and build a recreational center for NTI.
And this is the design that we have come up with.
At this presentation, the 4 groups will pit against each other their presentation and business skills and their newly acquired construction experience. The singular seriousness, the excitement, and the urgency that pervade the presentation and the prize-giving ceremony truly reflect the spirit in which the 1986 CSE Experiment Station project was brought to fruition.